Today we're building a decoder, one of the most important control circuits in electricity. If you ever wondered how RAM cells get selected, how registers are chosen, or how a CPU knows which thing to activate, this is it. We'll start with a classic 2 to 4 decoder wired live so you can build a mental model to reference. Then we'll build an analog style decoder that works off of voltage levels and thresholds. I'll start by explaining what a decoder is and how it behaves, and then we'll move on to the wiring tutorial. If you already know what a decoder is and you don't need an explanation, then you can skip ahead to the wiring tutorial. And also, leave a like and sub if you find this helpful. So what does a decoder do exactly? A decoder takes a binary input and turns it into exactly one active output. For a 2 to 4 decoder, we have two input wires, four possible states: 0, 0, 0, 1, 1, 0, and 1, 1, and only one output on at a time. We're turning two control wires into four selectable outputs. These two switches here are our inputs, A and B. Each switch either sends power or it doesn't, which is your binary 0 or 1. Each output is just an AND condition. Output 0 is not A and not B. Now note, in rough circuits, we have to treat the blocker as our NOT gate. Output 1 is not A and B. Output 2 is A and not B. And output 3 is A and B. Because these are AND switches, only one output can ever be powered at a time. When I flip the inputs, you can see that every binary combination selects exactly one output. That's a decoder. Now let's switch to an analog style decoder, something Rust is really good at. Instead of pure on or off logic, the input here is how much power or how many Rust watts are being fed into the line. Because you see, electrical branches let us say, I want this exact amount of power going through this path. That lets the output of a branch act like a threshold detector. And you've probably seen this many times on certain things like the BCN or the knee core, because those actually do use threshold logic. By chaining branches together, we can use threshold logic to build an analog decoder, selectively setting memory cells or outputs based on voltage levels represented in base 2 form. If you understand decoders, you understand control. And control is what turns wires into systems. Decoders are used to select RAM, choose registers, and route control signals for a CPU. Bigger systems are just this pattern repeated. And you don't have to stop at computer circuits either. Decoders can be used to select which base defense is active, which battery bank is charging, or which system is currently being enabled. The limit is how creative you get. Now on to the wiring tutorial. First, you'll make sure your switches and blockers are powered, represented by the white wire. Next, represented by the red wire, is your A line. You'll take that up to AND gates 1 and 3 from the top branch. Then, carrying the A line over further to the next branch, you'll take the outputs and carry it to AND gates 2 and 4. Now take a step back to make sure everything's right. Next is the V line, represented by the green wire. Take your power up to the side of the blocker, and then to the branch, which you'll connect to AND gates 1 and 2. Then carry the B line over to the next branch and take its outputs and carry it to AND gates 3 and 4. Now take a step back and make sure everything's right. Good, good. Now I'm just wiring up some lights here for reference. And then everything should be good to go. You should now have a working decoder. Oh, and make sure you got power. Next is the analog decoder. Start by wiring up the switches into the splitters and then the root combiner. Take the output of the root combiner into the branch that will be responsible for setting the memory cells. Chain them together, power out to power in. Make sure it's all good. Next, we will wire up the branches that will be responsible for resetting the memory cells. These branches will remain powered at all times because when the set nodes on the memory cells are unpowered, we want them to reset automatically. Now, wire up the reset nodes on the memory cells to the branch out on the reset chain. And then, wire up the set nodes on the memory cells to the branch out on the set chain. Now we take the power out on the memory cells and wire them up to the power in on the next memory cells in line. Wire up some lights for reference. And now we're missing one thing. Power to the first memory cell. And then your analog decoder is done. Make sure that the branches that go to the set on the memory cells are all set to 1. Make sure the branches under the switches are set to binary values, 1 and 2 in this case. And that's all. Now you know how to build a decoder. There are lots of different types you can use, like this 3 to 8 decoder here, but they all follow the same core idea. I hope you found this helpful, and that you take what you learned and apply it wherever you may need multiple points of control.